Good morning, everybody. The question mark here refers to the fact that I hope that you didn't get lost on your way to the breakfast or didn't get locked after the last session, because we have a interesting topic. Well, looks like clicker stopped working. Whatever. Wow. Looks like that. Now it works. Whatever. So we have a quite interesting topic there today, especially for the Android community, because annotations and the libraries built around that technology is kind of hot. There are a lot of libraries in that regard, and we'll look into some of them and what's under the hood. So, but because it's early in the morning, let's start with nice and easy. Let's start with the primer. Let's assume that you don't have to raise hands, but let's assume there is somebody who never heard about what annotation is. So this is it. This is an annotation. I choose that one on purpose. Let's look into the components. This is annotation indication. This is annotation name. And there might be optional parameters called elements. Yeah, I guess everybody knows that, so really like a quick rehearsal. But I choose that one on purpose because it all depends on the usage of the annotation, and this is a typical scenario. You have a piece of code, a method, which shouldn't have a parameter having a null value, so you do a check if that parameter is not null, and in the case it's not, you call the actual method called do really something. And what you can do, as there is a handy annotation we were just showing before called non-null, and that indicates that you don't really want in that scenario that value passed in the parameter to be null. So some people think this is the problem is solved, and they can also remove the check we had there, that if statement, and they feel that they are good to go. Some sort of magic happens, and it never fails. But the question is, what really happens? And the answer is not that easy. I would say this is the correct answer. That really depends on the setup. But if you have a default setup, default Android Studio, usually you get anything out of that annotation. So basically, if you remove that guard code, you also introduced a potential source of the crash, and a lot of people are really not familiar with that, because that shows the annotation there is some sort of stuff behind that. And for annotation, if you really want to just take one single piece, annotation is all about annotation processing. So in that particular case, that not null needs to be processed by either enabling that in compiler, or you can set up a sonar cube for you. There are many ways how to do that. But with annotation, without annotation processing mean nothing. So it's so important to always think, hey, that annotation needs to be processed to actually do something. There are two basic ways how annotation processing might happen. It can be either compile time, so when your application gets compiled, or when it's built and running on your phone. So that's runtime. Let's look into that first. So this is a definition of annotation we've seen before, like the real one. You can see the field retention that basically says if that annotation should be available at a runtime or not. This is a default value, basically meaning that they don't care. It might be available, but eventually might not. So if you want to make sure that annotation is available for you at the runtime, you have to change that retention policy to runtime, and then you have it available to you at the runtime during using reflection. So you can use stuff like that either you get your object, get class out of it and get a list of annotations for the class, or you can get a particular field. This is the my field is the name of that variable, and again get all annotations you have for that field. And in our case, would be the third one, get a method and get annotations for the method or parameters on that method. The problem with runtime annotation processing is that there is a performance penalty, but other than that, looks cannot move to the next slide again. Not really sure what's happening. Okay. Sorry for that. Oh, no. So there is a performance penalty for runtime because the processing and the reflection, which is usually slow, happens at the runtime. But other than that, it's really straightforward, and all those three calls I've been presenting is pretty much everything you need to do whatever annotation processing you might do at the runtime. But we'll look into compile time annotation processing for the rest of the talk because it's more interesting and you can do a lot more stuff there. So if you want to make your annotation information only available at the compile time and you want to discard it later, you set the retention policy to source, so it's only available at the source processing time. And then you run the specific specialized code, which will get a list of all annotations. And there is a code which will be generated first, and in the next step, it will be compiled. So it will be immediately after the build, it will be immediately available for you. Because there is a compiler step involved, you can also raise compile errors, so you can do a bunch of interesting stuff, which we'll be looking into later. And we'll specifically deal with the situation during the Android development, because most of the guys probably using Android Studio. Great tool, which has a support for annotation processing, but there are some specific steps to get it running. I don't know if anybody of you have experience with running your own annotation processor inside of Android Studio, but we'll get through the steps now. I don't know what's happening, really, like Keynote gets frozen from time to time. So let's see. Come on. So maybe quick feedback from you. Any questions, or is the written clear? Oh. So you quiet and I move to the next slide so we can probably continue. So in order to get annotation processing in your Android project, you need to create a dedicated module. And the trick is that module needs to be of the right type. It needs to be a Java library. If it's a normal Android library chosen from the gallery, it won't work because the tooling couldn't find the information they're looking for. So you have to make a module which is a Java library. And in that module, or even somewhere else, you create your own annotation. We don't get into the details now, but it's just a simple annotation. There is a simple string value with the default value. We'll get into the purpose later. And what you do, you create the class called Annotation Processor. The important part is it has to extend the abstract processor. I even don't know the package because autocompletion will find it for you. Also note that it needs to work on the 1.7 source code base, otherwise, again, it won't work correctly. Then you have to annotate that class with this annotation supported annotation types and provide the name of your annotation as a string literal. Two interesting things there to note. Well, the creators of the Annotation Processor library, they really using their own stuff, they're eating their own food. And also note that you have to provide a string, so be careful if you do any typo there, it won't be found and you probably won't get any information on that. So make sure that the name, the fully qualified name is correct. And then as a next step, Jesus again. I really don't know what's going on. Never happened to me before. So that abstract processor is abstract because there is one method which we'll need to implement. So they will be on the next slide once we can get there. I don't know why the computer is busy with that. So sorry for that again, but maybe again, time for the quick question if you have anybody. So it seems it's all clear to you. So hopefully we can get into the details. I don't know, that part would be difficult to do without slides. Because I actually want to show you some code, but yeah, here we go. So you have to implement that method I was mentioning before. This is the method signature. Note there is a set of elements, so that's a set of annotation which gets processed by that particular processor. And there is also a class with a funny name, round environment, which will provide you all the other information you need. So everything you will need to get extra information about annotation context or how you create that source code you will need to create, you will get from that round environment, and we will get into the details. To make it running, you need to connect your processor with the rest of the tooling. It's kind of funny way because you have to place the file called javax annotation processing.processor in that particular folder in resources. I don't know why they decided to name it like that, but you have to put it exactly into that place. It's just plain text file, and you put a fully qualified name of your processor there. If you have more processors, you can add a new line for that, as many as you want. And the last step to get that running is because you actually building stuff, so you have to modify your build configuration, your GRADLE file. So you add information that you're using the Java 1.7, the same as it was the annotation level. Then you have to define a task which will copy the output of your annotation processing into the jar file. and that task will depend on actually the module called processor to be built. So that's the first step. Your annotation gets processed, then output of that is copied into the jar, and later that jar gets compiled. So it's like 2 steps. Process first, process and generate some source code, and then compile it. So we have everything ready, so we can actually implement that empty method we have. There is a funny guy called messenger, which we'll get from that round environment, and you can basically then write messages into your compiler output. So we just loop through the annotations we get in that set and print some diagnostic. And if we run it, we get this single line. This is our annotation, which was called contract. And we see that it's enclosed in the annotation processor itself. So it's like a root context, but you can dive deeply into it. We'll see that in a minute. So we do something a bit more useful. We call a method called getElementsAnnotatedWith. That's our contract annotation. And we do basically the same. We again print some diagnostic into the compiler output, and that's what we get. We have a main activity, which you will see soonish, which has 3 methods which get annotated with that class. With that annotation, sorry. So we have basically the tooling ready. So now it's time to do something really interesting. So what we can do, I would say, well, you can do a general purpose library, but it's a great start to try to tackle some, like your personal problem you might see in your latest project. I did exactly that. I was working on a project for kind of a big company, and they try to follow all the like modern trends, and there was a lot of guys who were really into the MVP pattern and tried to apply it even to stuff where it didn't really make sense. And well, actually I think that MVP is not really a great match for Android for various reasons, but I guess you understand the pattern. So you might eventually have something like that MVP contract interface where you have methods of your view and methods of your presenter, and that gets in the middle. So I think there are 2 major problems with that. For me, it's basically abuse of the interface concept, because that interface is used just once, and you shouldn't do that. But well, the people who invented that pattern says that's way to go. And also, it's kind of abuse of a override, because in your implementation, you have to put there the override. But if you think about it, it's kind of problem of Java. There is no annotation for implements on a method level. So you have to use override, even if you're not overriding any method from the superclass, you are just implementing the interface. And if you have a little bit complex structure, you might have 2 methods with the same signature, which might eventually implement 2 different interfaces, but you don't get that information. And you also have to write that interface by hand. So it's a lot of effort, at least for me it seems like a lot of effort, which gives you a little value. So I thought that we can eventually have annotation processing to do a bulk of work for us automatically. So what I tried to reverse the flow. So you would define that marker annotation called contract, which has a value, the name of the contract. So if you don't provide, it will go to catch all interface, but you probably don't want that. You always want to provide the name of the contract. And once you annotate the method with that annotation, those interfaces I was presenting on the previous slide will be generated for you automatically, and you can use them. So let's have a look at a sample usage of that. So this is like a typical activity of your Android application. And there is a method doing exactly that. It's annotated with that contract annotation, and whenever the application gets compiled, you get that interface generated for you, and that method will be listed there. You can do even more crazy stuff with that. You don't really have to put there a string literal all the time. You can also define a constant string, which you pass as a value. On the second method called double agent, you see that your method can be actually part of two interfaces or two contracts if you have that, and it's correctly handled. So you see that it's not overriding by accident two interfaces, but you actually see the names of those, and will be listed in both. And the last one is just usage that you don't have to provide a value, and this method will be listed in that catch-all interface I was mentioning before. So this is the complete example. Hopefully it's still readable. It's a bit of code, but should be readable. You can also notice that you can actually make the main activity to implement that contract interface, which is on the top right corner. So it's immediately available to you. It's kind of funny because you type the name, that aux contract, the contract gets appended in front of that, but that class immediately exists. Well, the IDE will compile if you start to type it, but as it gets, if you have an instant compilation, as it gets compiled, it will be resolved, or at the first build, it will be resolved for you, and then you can use it. So it's kind of like a magic, but it's not a magic. So that's what I just said. There is all the support you can get from the IDE, so you can drill into it. You can immediately see that file. You can the auto completion is working. You can get a reference to that, so you can see who is using the interface. It's the first class citizen for Android or for Java development. The only difference is that it's generated at a compile time, so you don't have to do that mundane task and type it by hand, because it's just automated stuff. So let's have a quick look how this particular feature is implemented. We have the same method we had before, but now we do actually the real thing. We loop through those annotations of a contract class and store their values in a hash map. So if we look, if we encounter the unique name of the contract, we create a new entry, and that's like a second level of hash map. And in that second level hash map, we will collect all the method names. So we'll have, for each contract, we'll have a hash map for the names of the classes, which we'll need to generate the interface later on. And that's exactly what we do. Now we loop through the those entries in the hash map and create new interface for each entry and write methods. So those are high-level methods. We'll quickly look how they look like inside. So it's kind of quick and dirty implementation. You probably don't want that in production, but for our purpose, it's perfect. You just create a string builder, because we'll be building Java source code by hand. You see, you're appending like a package. You have to create the interface, and you have to name it like contract. This is a start of the name, and then you append what you find in the hash map and pass it back. This is the footer, just a closing brackets to make a compiler happy. It needs to compile. If it's not compiling, you have to debug that. So it might be a bit tricky, but it's possible to deal with that. And this is another method which will actually write the name of the method into the body of that generated interface class. And as a last step, you have to take that string builder, or that class we just defined, and write it into the file. This is again where that round environment, it gets handy. There is a method called getFiller, and you can call create source file. You provide the fully qualified name of that source file, and you get a stream, and you just push your data into that stream. Stuff is done. Well, this is where those files are generated. This is the default location. It's in the build trees. That's probably like a drawback, because if you don't know where to look for them, it might be a bit awkward to find them. But again, it's first-class citizen, so find like command O and type the name, will find it for you and open it automatically, so it's not that difficult to find them. And you can use them any way you want. You can extend that stuff, you can whatever you want. It's just normal code. So this is an example of 2 of those interfaces we just generated. You see the names of the methods. You see that double agent which appears in both of them. There is no particular order, but it could be obviously sorted by anything. And for the simplicity reasons, we just don't really look into the parameters. We always expect that they will have a void return. They return nothing, and they don't have any parameters. But of course, it's possible to look into actual parameters, actual return value, and see if there is a match. So, but that's not in the scope of that example. There is a source code of that particular example available. I just uploaded it to GitHub today. So I would like to, in that perspective, would like to thank the organizers that yesterday they let me out of the speaker's dinner before the midnight, so I had actually time to complete that and upload it. It's really like there for 40 minutes or something. And maybe we have time to look into another example. This is a bit more full-featured. This is how you can eventually incorporate a networking stack into your application. And again, people tend to write patterns. They tend to write always some sort of like interactor which will deal with the network activity, provides you cases for a successful return of your networking data, or gives you a method if there is some error. And again, it's a lot of boilerplate code you have to write usually, and it's absolutely not necessary to do so. And it also can like wrap that networking library. So it's hidden for you, but it's still there. You can access all the features under the hood if you want to, but it gives you really a streamlined interface based on annotations if you don't care about the details. So for that example, I choose this guy, Fast Android Networking. It's a cool library. Works really well if you're familiar with that. But any other networking library like Wally or whatever can be used. So this is, again, the example of the usage. The key is that remote data annotation, which has as a value, it has a URL where you get your data from. There is a tag, so that defines the name of the interactor which will be generated for you. And it also defines a tag, so you want to, for whatever reason, if you want to cancel that network request, like a network is slow and you want to close the activity, you can still find the networking stack component and call the request. You can find it by the name and you can cancel it. So it's no magic. It just hides the stuff which you probably don't want to care about most of the time. And then you notice there are two other annotations, remote success and remote error, annotating 2 methods which get called in both scenarios. So if you get the data, they are passed to you as a string, so you parse the JSON you're getting from the remote server and return it as a string. or you get an error which is also returned to you as a string. Again, as simple as possible. It's probably not production code, but for the illustration, it works really well. And it's really simple. You have a minimum of stuff, happy case, error case, and declaration where you get data from. That's all you care about. You can do a bunch of other stuff. You can also directly annotate the variable, like in this example. So if that's the case, if it's not on a class level, you don't need to implement neither of those methods I had before, because if there is a success, it directly goes to the variable, and if there is an error, nothing happens. So it's even easier than that, but it needs to be, the annotation needs to be on the variable. If it's on the class and you forgot to implement that on remote success or remote error, this is part of the contract we have, and that's a cool thing that you can eventually like enforce. We'll look into that later. So this is the declaration or definition of that runtime variable of that remote data annotation. You can see it's a little bit of code. Hopefully it's at least a little bit readable. There is a lot of, that is a URL, the tag we've been talking about. There is a default value for the tag, so you don't have to provide it. And there is a lot of networking defaults. So if you don't specify that, you will get a GET. But if you can easily get a different request type if you want. You use cache if you don't provide that, but you can always force the fresh data. And you can also deal with the parameters, but I won't go into the details on that. And for that particular case, we've seen in our first example, we've seen that we generated the code really like by putting together pieces of strings, which is kind of ugly. The guys who did a lot of annotation processing in Square created a nice library called JAVAPOET, which can write source code for you, and there is a Java API, so we'll be using that. So at least you see some examples of that. So this is how it looks. There is a high-level method. You add their class, which has a public modifier. You add there a private field, the modifier private. There you add some methods, the constructor, you add another method, and then you call build, and you basically get your string out of that. No magic there, it's just nicer. Same for Java file, it automatically generates the file using, and then you can write it to the same location which you get from the round environment again. And the cool thing I was mentioned before, you have access to various information about the context. So in this case, I'm looking if the annotation element is class, the top line. I'm looking inside that class if there are two methods annotated with remote success and remote error down there. And if I cannot find them, that's a violation of the contract. So no, it's not a valid stuff. And if I cannot find any of them, I can do using that messenger we've seen before, but this time I'll provide diagnostic kind error, which will raise a compiler error and the application won't compile. So people tend not to read documentation, and no matter how hard you try to provide a nice API, they often misuse it. This is extremely efficient way how to make sure that people are using it right, because if they forgot to implement the method, you can make sure that it's there, because otherwise the compiler error gets thrown, and everybody will notice that because they need application to get compiled. So that's really awesome thing to do. This is the compiler error you get if you violate that. So it's normal compilation error. You can provide whatever information you want there. So that concludes the solution we've been brewing. We won't go into any more complex details. Again, I plan to share the source code for that on a GitHub soonish. So if you want to have a look, you can. But let's have a look at the existing libraries, which are using exactly the same technology to do stuff and do some popular things. This is probably the most prominent of them. I don't know if you know that. There are two things to mention. It's actually DAGGER 2. First thing, don't want to overload you with information, but the first G stands for graph, so it creates an object graph for you and allows you to do dependency injection. So instead of passing stuff like a context around to drill it down to the place where you actually need it, you declare that you need particular dependency to be present with annotation called inject, and then there is a provider which will, as the name implies, will provide that resource, and the library will connect those together, so it will be available for you. And they also, because they have a graph of the dependency, they will check the life cycle, so it will be only there if it's needed. And another interesting aspect is that it was originally developed by Square many years ago, and they started with a runtime annotation processing, but because it's application-wide and you can have a lot of code to be processed, there was a visible lag at the start of your application, which was not really nice. So that was like a natural extension of that. So the next version is using the compile time annotation processing, and it's really powerful. Another example is coming from Instagram. It's called IG JSON parser. There are many libraries to parse the JSON. This one is also compile time annotation processing, so you don't have any performance penalty. That's also very popular one called butter knife. If you write a UI in XML, then usually in your activity there is a lot of, to me, very ugly code with that find view by ID, and then you have to typecast it to actual type to use it in your activity. This hides that for you, so you basically annotate your variable and it will connect it automatically to the layout. So it saves you a lot of boilerplate code, which is really ugly and nobody likes to write that. So that's awesome, and it's very popular, again, using exactly the same technique. Probably the last one, it's actually two libraries which are intertwined called Dart and Hansen. Also check it out on GitHub. It's dealing with scenario if you have two activities and you want to pass a parameter into the intent which calls the second activity, like a start activity for result, or just start the activity and you want to pass anything as a parameters. So you normally have that bundle and you have to pack your stuff into that bundle and make sure that receiving activity is unpacking the bundle correctly. Here, in both cases, you just declare annotations, and all that code is generated for you whenever you have intention to do that. So again, it saves you a lot of time. So those were some popular examples where it actually makes sense, at least in my opinion, it makes sense. There are some other examples where it might not be that great idea. I don't want to mention those libraries by name, but this is one example. There are few libraries. If you in that previous scenario, if you use bundle to send some data around, a lot of people are using parseable, and because parseable requires to write a lot of boilerplate code, they created annotation processing for that. But the problem is that parseable is not really a protocol which should be used because there is serialization, which doesn't need the boilerplate. If you go with just plain serialization based on reflection, which is slow, but you can write exactly the same like parseable, and then you get roughly 2 or 4 times more performance. But people, and it's not even that, you don't have to write that much code for that, but people, for whatever reason, they prefer the parseable, even if there is no benefit to use that. And they say, well, there is an annotation processor, so it hides the work for us, but still it's an inferior solution. And another example, again, there are cases where you can see that people tend to write a complex language, the complete domain-specific language in that annotation. So that annotation has another annotation inside, a lot of parameters, and gets really complex. So you can have 2 pages full of annotation and nobody really understands that. So you can do that, but make sure that if you do something, don't overdo that just because it's technology. You can harness, try to make your interfaces simple and try not to overdo the stuff. So we are getting to the end. So what are the takeaways from this session? The first, the important one I mentioned at the very beginning, always think that annotation always needs any sort of processing. Without processing, annotation is totally useless. And it's really great if you understand what that annotation processing means, even if you don't write that code by your own, but it's good to understand it. Another takeaway, I think it's obvious, there are 2 ways of annotation processing. We barely touched the runtime one, but we discuss extensively the compile time processing. And it's really nice to go through exercises as I provided. And it's also nice to have a look how libraries like DAGGER do the stuff behind the scenes. And it's really useful to see what is the generated code, try to understand why it looks like that. And it's especially in the DAGGER example, again, I've seen a code where there were like leaks of typically of a activity context because people don't understand, they just throw it around, and all of a sudden, well, they have the worst possible scenario because, well, if they have a static activity somewhere in somewhere defined in a singleton, they will be exactly in the same shoes, the same problem with the memory leak, but they don't have to link a big library. They don't have to do the compile time processing every single time they compile. But because they don't understand, they easily make mistakes. So don't make those mistakes and try to understand how it works. And another thing is, I really like that you can utilize a compiler. So it's awesome that you can write a piece of code and make sure that a compiler does a lot of work for you. So you can enforce your contracts. You can also provide, because as I said, it's a Java first-class object. So you can build on top of that API, even if it's a generated one. So those are the important steps I wanted to re-emphasize. So that's end, and we still have like 5 minutes for the questions. We never had the questions before, but hopefully there are still some questions. Yeah.
One.
One question. Is it easy to write a unit test for annotation?
You mean unit test for annotation processing?
my own annotation, and I want to test that code, my annotation which I created. Is it easy to test it?
Yeah, well, actually, the unit test for that, it's no different from any other code because it's just normal Java code. You can directly call it in unit test. It's easy, so I don't see any difference. So if you would like to write the unit test for the class I did before, it's easy. So you just provide there some input and check the output like in any other unit test. No difference. What is a little bit more complicated is if you would like to debug that code. That's also possible, but not the normal way that you just start the debug and set a breakpoint and expect that it will break there. You basically need to attach debugger over ADB, and well, you can do that. It's a little bit of work. You can do that. Anybody else? Awesome. So thank you very much. If you have any questions, shoot me a line. I'll be happy to answer questions. I hope I'll also publish the second example I had on the GitHub, and hopefully it was interesting for you and you'll start using that if you haven't already. So thank you again.